Hey, what's going on? This is going to be a review of nested fractions and algebraic expressions. Every day I try to go ahead and put together 10, 20 minutes of mathematical, reasoning and competency. So that way I can, prepare for grad school and also taking the rest of my calculus too in the summer, in the spring. So let's go ahead and move to that right now. So which expression is equivalent to 1 over b minus 1 over a? So we have 1 over b minus 1 over a. So I remember what I was doing yesterday was the idea of let me see. I think I was supposed to go ahead and say 1 over b, 1 minus 1 over b over a. We're supposed to get the a over b like that. And then we would end up with 1a ba minus b over ba, right? And then you still would have 1 over b at the top. So let's go ahead and bring that down. Like that. So I don't think I'm going to do that just yet. So we're just going to just have it where, excuse my nose is running. Sorry. All right, so yeah, we have that. And now that we do this, we say we would have something equal a minus b over ba minus ba. And then you would also have, just bring it over here so I can make it that, and then you have 1 over b. So let's move it over from I'll use the text I have right here. Yeah. So now we have that. And we have 1 over b. It's not that equal, which is 1 over b is equal to this. Now we would have to do something where, see if we can, we can't take the subtractions out just yet, but we could do that maybe, where we can pull the, I don't think, maybe we're not. Yeah, we could, maybe cancel out the b and cancel out the a, right? And then just end up with 1 over b. No, that won't work. Well, let me go ahead and do what I normally do, which is take 1 and I'll plug in b equals 2 and a equals 4. So then we would have 2b, and then you have 2 minus 1 over 4. So we can't do this like that just yet. So I'll do the same thing I did over here, right? That it's 1 over 4. Is that plus 8, and you have this is 8 over 2, and then 4 minus 2 is 2 eighths. But that's what we would get there, and then we would have 1 over 2 at the top. 1 over 2 at the top is kind of like saying you have Oh, right. Now I remember now. So now I can have 1 over 2 divided by 4 minus 2 over 8, like that. And then we can flip that. Yeah, all right. So that makes sense. I can do that. So now I think I have an idea of what I can do. And sometimes I like to plug in numbers and actually play with the numbers to see before I actually start doing it. So, because I would know how to do it if I was using the actual. If I was using numbers and no letters. Letters sometimes throw you off. You don't know how to move around. So if 1 over b, then you have this piece of b of a. We will start to multiply a, b, like that. And this will lead us to equals, I usually put it over here and I say b over a, that's a minus b, like that. And then we can go ahead and move this over to the side, and then we can say 1 over b divided by that. Then we can go ahead and we could say, if we want to multiply it, right? What we would do is that we will take this, we will duplicate and bring it down here, but then we will move this on top and put this on the bottom, like that. And then we will duplicate this as well and bring this down. So when you multiply, you just flip it. Now we can start doing like we could say b times ba, which would equal b times ba, like that, and then you have 1 times ba, 1 times ab, which would just be a over b, like that. You can multiply this, right? You can get 2b times ba, and then you have 2b minus a. Or not 2b, you have b squared. It's not b squared. And then you have ba. So where is ba? Where is b squared times a at all? I mean, here, this looks a little bit like it. I'm going to go with this one. Only because it has a b squared, and that's as far as I got. No. Okay. So that can't be it then. So it's b over b squared. All right. All right, let's see what happened. What did I do wrong? They don't give you an explanation. They just... So a minus b. I gotta look at that again. All right, so let's keep going. You have here, which expression is equivalent to 2 plus 2x over 4 minus 4x. And then this 4x here would basically become 4 over 4 minus 4x, like that. And then we can also do 2 over 2 minus plus 2x. And because we have this over here, we would probably want to get this x to be the same. How would we do that? I think we would put 4x here and x here, right? Does that work? So you have 4x, 4x. You have 16 and 4x. So we end up with 4x minus 16 over 4x. And then the top one, well, that will happen too. We would get like a 2x at the bottom. And then you would say 2x plus 4 over, 2x. Go ahead. So then you would have that. Now you can do something like, it looks like we're going to be plugging out something, right? We have 2x plus 4 over 2x. Maybe I would actually would do this with this, and be divided by 4x minus 16 over 4x. Now we know that when you multiply, I'm using this dot for multiplication. You flip the denominator, so 4x minus 16. You can go ahead and now say 4x. We'll do this multiplication, and we'll get 4x minus 2x plus 4. Then you do this, and we'll say 2x minus 2x 16. Then we can plug out the 4, right? How do we do that? We could take the 2 out. We'll end up with 2. Or maybe I would multiply it. Yeah, I feel like I'm close. Just let me see what happens now. So we have the 2x is 4x, right? Yeah, the x get puts on both sides. Oh, x get puts on both sides. Oh, that changes a lot. It's not. So yeah, x gets put on both sides like that. That's what it means. And then we would end up with x on both sides. Now that the denominators are the same, then we can flip it. Right. Okay. So we do end up with something like this. I just forgot. We cancel out this the like factor term. So that 2 would come out, right? And then you have 4 here, we take 2 out. Okay, great. So that's the issue. Oops. Yeah. So the answer is x over 2. This. All right. All right. So we have here, and we have 3 plus 3 over x. And we have the same one before, right? So 4x. So what we do is that I will grab this, move this down here, and then we'll say equals, which would be 3x plus 3x over 4x plus 4x. And this would also become 3 plus 3 over x. And then you have 4 plus 4 over x. And then we go ahead and move this up, move this over. I'm gonna put it here. There's no room. Let me see something. Okay. And I can move this over here like that. Yeah. Okay, so now we have that. So now what we can do is that we take this and okay. And then we put the division in the middle. But then we go into multiplication, right? And then we will flip this, put this in the bottom, put this on the top. All right. So that way we don't confuse ourselves, we're gonna add a little dot. And now we're gonna start doing the multiplication where we end up with x 3 plus 3, and then x 4 plus 4. You would end up with adding that, right? Which would lead us to 6x, and then you have here 4x. And then we can pull out, and then we have this and 4x, right? And then you have 2. Well, we don't pull a 2 out, we just pull a 2 out here, and we end up with 2x, and we end up with 3x. And then there's a 2 on this outside, I believe. Yeah, I feel like I did something wrong. Let me go back to this. Go back here. And I would try doing these two crossroads at 6 times 6x would be 2x. And then you would have 3 plus 3 multiplied by 4 plus 4, which would lead you to 6 and 8. And that's 14. Well, no, 6 and 8 would be 56, right? 48. Let's just try that and see what happens. That would be x squared. Whoops. 8x times x is x squared. The x squared seems to be possible. But I feel like I get stuck with that. So we do this, we do that, this is okay. But then when we flip it, yeah, we get to that part. Oh wait, 3x plus 3. Oh, that's why I actually was, this is 3x plus 3. It was actually, he had x to both sides on the top too. Oh, okay. That's where I messed up at. So we start by simplifying the numerator and the denominator since 3 equals 3x over x and 4 equals 4x over x. Okay. So it's do this. Oh wow. Okay, so that's honestly the problem there. Oh, that made a big mistake. All right. Let's go back to 1 over y plus 1 over x over 3xy. Now, this is a little bit different. You have 1 over y plus 1 over x, and you have 3 over xy. What would you actually do first? If we had 2, x equals 2 and x equals 3, then we would say, oh, this would be a y. So we would say 1 over 3 plus over 2. You say 3 times 2 times 3. You would have to kind of get the 3 divided. All right, so let's try that. So we can put y on this side, and we can put the x on this side, right? And then the x would get added to the top. And that would equal x plus y over xy. And then you have 3 over xy. Then we would take this particular duplicate it, bring it over here. And then we would take this, bring this over here, take that, bring it over here. And then we would go ahead and divide, which would ultimately equals, actually, you know what? I'm going to keep duplicating it because I think that's really cool to do that. All right, so take that, we duplicate, we grab it, bring it over here. And then we bring that on the top, bring that on the bottom, and we bring this, and then we will add a multiplication symbol, and then we start multiplying. I think we cross multiply. So we end up with xy times xy over x plus y times 3. Okay. This xy plus xy would equal x squared x squared x squared y squared. And then you have here 3x plus 3y. And then look at these things now. We can cross multiply these out to get an x at the top. And cross both outside that. So we end up with a 3 plus 3 and xy, like that. Oh man, I feel like I'm stuck again. let me not cross multiply. Let me try to do it with let me try to go ahead and do it with 3xy, and then you have xy times x plus y. Because now that crosses out. Yeah, that looks a little bit better too. So yeah, because sometimes I just like to look at it and I see that that looks weird. I like that one. No, and it was the other way then? It has to be that. Okay, yeah. So what happened was, it looks like I'm gonna write this down properly so I can do it later on. Okay, yeah. So I didn't go ahead and get I didn't get a chance to get any of those answers right, but I'm going to look at this later on and try to solve it for my own for my own benefit later on. So until I get this right, I won't take the test. So there's a lot of actual things that I want to be able to do. Like I guess that there's like when I try to solve the problems and you have like, you know, intuitively trying to like add different pieces on, I want to really know why that is actually happening. And if I see the right system, then I can move forward with it. Kind of like how if you're trying to learn solve a puzzle. So